All right, well, I went to GeoGebra, which is a website kind of like Desmos, but it's a little more geometrical, right? And so it's kind of cool what you can do. So over here, I created this function, x cubed, and then I went ahead and I added a point and labeled it A, okay? And then I went ahead and created a function for the tangent. Now, the way you do that is you go down, where is it? Somewhere around here. Yeah, you go down here, you click that, and then you click on the point that you created, and then you click on the graph. And it'll automatically create a tangent line through the point as a function. And so that's what this means. This G function, notice the colon, is the tangent at point A using the function f. That's what that means. And notice it's creating the equation. Okay, so notice that the slope of this tangent line changes as you go around the curve. So what function would give us the slope of that tangent line based on x? That's the derivative. So if we wanted to find the slope of the tangent line here when x is 1, since it's an x cubed graph, we would take the derivative of x cubed and use that when x is 1 to find the slope. Okay, so the function that we're dealing with is x cubed. We take the derivative of x cubed, and this becomes 3x squared. Okay, and so right here, the tangent line when x is 1 is going to have a slope. Okay, so when x is 1, we put that in here, and we get 3 times 1 squared. So the slope there should be 3. Okay, and then notice the y value when x is 1 would have been 1 cubed. Okay, so at 1, 1, this is a slope of 3. And notice you can see that. Notice you go down 3 to the left 1, down 3 to the left 1. And notice we can use the symmetry here. Apparently, we should be crossing the y-axis at -2 for that line. So we can already write the equation of the tangent line. If we wanted to, we could create it using point-slope form. And we'd still be able to get the same thing. So we know we're crossing 1, 1. We use the derivative function to find the slope of the tangent line when x was 1. And so we could have just did this. Right? And notice you'll get the same thing. When you multiply the 3, this becomes -3, and then you'll add the 1. And so you get -2. This is just a little shortcut I do. And that might be very useful, using a particular tangent line, finding the equation of the tangent line, using the derivative to find the slope of that line at a particular x value. Because again, the derivative function gives us the slope of the tangent lines based upon the x value of the point. If we want to create the equation and we can't use the visual, we find the y value. We already knew the x value, and once we get the slope of the tangent line, we can use point-slope form, and we can find the equation of the tangent line. All right? Now, notice what happens as this thing goes down. Slope is changing, and then it gets to right here, and it becomes horizontal. And then as we go to the left, boom, the slope starts changing again. So this is a unique graph because notice the slopes of the tangent lines are always positive except at that point. At that point, at the center origin, 0, 0, we got a slope of 0. And then after that, the slopes of the tangent lines start curling positive again. Well, let's change this graph. So I'm going to go over here and make a little change. Okay? I'm going to make this x cubed minus 2x, and then I'll just do plus 1. So that'll change it. And now notice we got a little more complicated of a graph. Notice now we got 2 humps. Okay? And notice when we move the tangent line, when we move the point, we get to this hump. What's the slope of that tangent line? Okay, random person. Let me pick that up on my phone. So random person. Justin, what's the slope of that tangent line, Mr. Sang? What's the slope of this line?
The slope?
Huh?
You mean by like?
So the horizontal line through A? What's the slope of a horizontal line? It has no rise.
Oh, it's I know this. Wait.
Here, look at my hand.
0. So that means it. Yeah.
That's right. Okay, and so notice as we move that point to the other hump, as soon as we're on that hump, now this is a little hard to do with the mouse construction, but okay. Just got to get it right there. All right, it's not perfect. So notice this one also, if you could get it right at the bottom of the hump, the slope would be 0. All right? And then as you go to the right, you got positive slopes. Notice in between you're using negative slopes. And then as you go to the left side of the upper hump, you got positive slopes. Okay, the top of this hump is called a relative maximum or a local maximum. And that's because in this little small region, that's the maximum Y value. Whereas this other hump, the bottom hump, okay, that's called a relative minimum or local minimum because just in this little bitty small region, that's the lowest Y value. And when we find those points, we use the derivative equal to 0.